We'll start. Alrighty, everybody. We're going to move up to a different activity. So partly when I'm presenting these things, I'm trying to give you some things and sidebars of how you might act as a teacher. And then I'll try to actually run us a little bit like a classroom of students. On this one, I think there's going to be more student exploration time where there's going to be more, hey, let's explore once we get through the concepts. The activity that I'm describing here probably works best for 3rd grade and higher, and you can take it all the way into high school by making things more elaborate. I've seen people do some of the figure type numbers in the Berkeley Elementary Math Circle with their kindergarten through 2nd grade group. It's a little bit of a pinch because to really get into the nice stuff, it's nice to have multiplication for this is why you want 3rd grade. So I described this as mathematical mountains. And so in getting into the mountains, I did a nice round on Grand Teton a number of years ago. You have to start out by going through a mountain pass. And so we're going to make mountain passes. And so I'm going to let the kids make mountain passes. But before I do, I'll make a sidebar for teachers. There are some interesting questions we can ask about surfaces that are at a higher level than the 3rd grade. Some of these questions might be, if you have a surface that has a straight line in it, is it a plane? What do you think?
It has a straight line, is it a plane?
Does it?
It can be an irregular surface and still have a
Sure. So, so what if it has 2 lines or 7 lines?
If they are parallel, it can still not be a plane.
Sure, if they're parallel. So what if you have a 1-parameter family of lines, sort of infinitely many that you can move from one to the other continuously? So that's a little unclear, but so infinitely many parameterized by 1 real number. So if a surface has a 1-parameter family of lines, is it necessarily a plane?
No.
He's drawing.
Yeah, it could be like a cylinder, right? 1-parameter family of lines. What if it has 2 1-parameter family of lines? Does it have to be a plane? A family of lines in this direction? A surface. A surface. So there's a family of lines in this direction and a collection of lines in this direction. They all line up. Does that have to be a plane? You have to make straight lines. So,
The lines
answer.
are straight, then yes. Yes.
So we have a conjecture that if the lines are straight, that it has to be a hub.
Because 2 intersecting lines would define a plane.
So let's think of that. And so we have a conjecture, yes. I heard Consuelo, I heard somebody else. Somebody else want to put their name on this as well? So.
Those are all Consuelos. Blaming it, well.
I was told it's okay to
No
fail.
guts, no water. Yes, it is great. This is the way you make mathematics, is you just start saying stuff. There's nothing wrong if you say 1,000 wrong things and come up with 1 gem. That's brilliant. That's great. Mistakes are wonderful. You just start blurting stuff out. That's how you think. There's nothing, nobody gets it right the first time. When I write a 20-page paper, I'll write 700 or 800 pages of stuff, and I'll throw out all but the 20 good pages that have something that's not, oops. So conjecture if a surface has 2 1-parameter family of lines, it is a plane. So we'll think about that. Actually, gets into really interesting mathematics very quickly. You look for lines on surfaces. If you make your surface, a polynomial in the variables x, y, z, you give yourself a cubic polynomial and say, does it have straight lines on it? In fact, yes, there's a cubic polynomial that has 27 straight lines on its graph. That is not the first thing you would figure out, but it's definitely a kind of cool thing to figure out. There's lots of questions like that in a field of math called enumerative algebraic geometry. So we said mountain passes. So we're going to build some mountain passes. Like this. So the way to build a mountain pass is, I do have two things to say. So I could have two people work at once. I take a file folder. It has a little fold in the middle, and I cut a square out of it. There's other shapes that you might want to cut, and you might want to make a different configuration. That'll be a question for later. Then you fold it up. Actually, I might first fold it and poke a bunch of holes along it like this. If you make them evenly marked, one way to make them evenly marked is just a ruler in every ½ inch is a pretty good size range. Once you have one made up, you can put little pen dots in each of the dots going around like this, using this as a template, and then use a hole punch and make another collection. So if somebody wants to work, I'm going to give you several different building projects. If somebody wants to do this with dots and a hole punch, you can make another template there. Actually, as soon as we have as soon as you have a template and a roll of thread, you can start making a figure where we'll have a one-parameter family of lines. Basically, I'm going to join the dots on the opposite sides of the square. I'll put a thread through here, just pull out a big segment, run it through this one, through the back, through here, then over here, then through this one, through here. But when I connect them up like that, I'm going to connect it with a folded like that. And with the thread, you can do this with yarn, you can do this with pieces of paper, you can use different building materials. Does somebody want to make a mountain pass? So are you, I see. I'm going to have a fight here. As soon as you get the holes punched in that, we can pass it on to, there will be other things. There's going to be mountains, and so you go from one side to the other, and
Do you want
just
me to
keep
tie
going
it
through.
off?
Well, actually, the suggestion here that makes this work better is just leave it loose on the thread. Maybe give a segment that'll be across your arm and thread through. Once you get that threaded through, your end starts getting short, then start pulling more off the spool of thread or the ball of yarn. If you get too big of a thing, you'll start getting length, then that'll get turned into tangles. And then you can pull extra thread through the area, and then you tie off the two ends once you're at the end. So we'll get more of these. You can practice. One thing, oops, I missed this trick. Before you get too far along, having little segments with your file folders that you cut trapezoids off the other ends, you can use whatever cardstock, whatever comes in the junk mail, paper, cardboard, whatever. Putting in at least one of these, or maybe two of these, with a glue stick into the corner will help keep your mountain pass straight. And so here, before you thread too far, you want to fold two of those and move in sort of a third way. Hold it at an angle. You should have two of those in there. If not, we can
Like this?
find it. Yeah, maybe a little closer to the center, but yeah. There. Here's another, if you like. Sure. And so, sure, if you want to do, I can pass this one on to unit to make mountain pass. So we have other construction projects to do. And in fact, let me see this for half a second. Each of these things starts out as a square, so I can attach the dots on the top and the bottom, corresponding dots coming through with one color thread or string. Then I can attach the dots on the sides with a different color string going across this way. And in fact, now what we're going to do is make the addition table, and we're going to make the multiplication table out of Legos. Though you can in fact do this not only with Legos, you could do it with cheese cubes and toothpicks, sugar cubes and glue, styrofoam balls and toothpicks, tennis balls, marshmallows, tiny marshmallows and toothpicks, or big marshmallows and toothpicks. Using different materials will give you different kind of classroom feels. If you're going to use the sugar cubes and glue, do it at the end of the day when you're passing the kids off to somebody else, because they will eat it up and get all sugared. But we have Lego plates here. So what we're going to do is we're going to make, let's say, an addition table going up from 1 plus 1 up through 6 plus 6 in corners. Maybe a multiplication table doing from 1 times 1 up to 6 times 6. These are going to be your mountains. In fact, I can open up some more Lego things. In fact, another multiplication table that's a really nice one to make is make one on a piece of graph paper with rectangles. So you'll have a 1 by 1 rectangle, a 1 by 2 rectangle, a 1 by 3 rectangle. You could also do this with Legos of different colors. Let me get it. Yes? So these are going to be stacks going high.
Or do you do it vertically, or?
That's perfect. So the height, the answer goes up, and then the grid, so you're doing addition, so I guess you're starting at 0. So 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 2 is 2, is your addition table. We'll do a multiplication table.
These are my 1 times things.
Maybe put the squares right next to each other so there's no gaps, and you'll have a nicer looking mountain. And so the first part of this exercise starts with make something.
Yeah, we're ready to do something. Okay.
Let's make another multiplication table. Multiplication tables are cool.
Much cheaper than we did.
So,
Yeah.
Yes, but.
yeah, but that's interesting to compare, and just compare the addition table to the multiplication table. By the way, I did a shortcut on one of the mountain passes. Look at what it looks like.
Oh.
I want to do it.
Zero. Starting with 0 times 0, do you want 0 involved?
Let's not do 0, because that just leaves
Right.
2 blank rows.
Exactly.
If you want to use 2 blank rows,
No.
sure, I mean, just leave, so
We'll
sure.
just start with 1 times.
The point is you
one.
can do it, if you start with the 1 times 1
Yeah.
here, now
Uh-huh.
you've got these.
Okay, perfect.
So we've already done the 0
Right.
rows. Yeah, let's try to go up to 6 times 6. Does somebody else want to do a multiplication table on graph paper for us? And they don't have any more bases. Oh, is that true? No, I do have more bases. So I've got
Let's
both.
switch colors, let's switch colors.
Yeah,
I've got
The
the
odds
whole
will be
color.
in yellow
So
and
you can
these
think
will
about
be
what color
in
coding
red.
you want to
Like
use.
this is the 1 times
So,
table, 1, 2,
I have
3, 4.
lots of the cut file folders. I've got the
Two,
glue,
right.
the hole punch, the things like thread. I've got lots of Lego things that I can open up, and lots of Legos, hand people. Lots of these. So, I thought about having you guys make these things last night to get us a head start so we could do the math. But somehow construction is also interesting.
No,
The construction is very
it was her
valuable
birthday, I
for-
didn't know, my friend had her birthday
It's
yesterday.
kind of fun.
It's
and
fun,
you
but I'm
She was
also,
going
they
home
don't
to her
do this
family to
stuff, we
have
don't
all
do
this
this
stuff.
anymore.
wanna Lego
Yeah,
plate?
sure.
Having
kids play with things like Legos and get some spatial idea of multiple
Hey,
pictures.
would you like a Lego plate?
I'll do Legos.
You do Legos? Have you finished your, or paid it off your
We're
house?
working together on it.
Good. Well, if
That was a nice
somebody,
one last night.
Oh, is it good?
I think
But this is kind of
I
like
think
Lincoln
it should
cubes,
just
right?
put
That's
together.
what, a lot of the lower grades use,
Yeah.
Lincoln cubes.
Yeah, but this is.
yeah, well, yeah, exactly. So you could use Linker cubes, apple chunks, right? You can
Use what?
do it in the cafeteria.
Yeah.
Apple, you know, get an apple and dice it, right?
It's very relaxable work, isn't it?
Do you have worksheets for the Lego?
I do, I will pass out the worksheets, I've got 2 worksheets for this, and so I'll actually show you what the activity is after we get the materials
It's
for
not vision, it's not really.
So you wanna
Should we
do
tie
that?
all these in? You're gonna put them
After you get it all filled up, then tie off the end, so we'll do one more, it comes from here to here.
The 0 to 0, then this is 1, one times 1 to 1
Yeah,
is
and
6.
then- so that whole comes through
2,
here,
15
and
times
then tie a square knot around
Just
there.
that far.
And then you wait for,
With multiplication.
wait till we finish with the green thread, and then with the green thread off in this direction.
Oh, I have.
Let me ask a question about this, let me hold up my mountain pass that we're walking into. You see this mountain pass? What does this mountain pass tell you about this conjecture that if you have 2 one-parameter families of lines, you're a plane?
It's not true.
Takes more than 2.
'Cause yeah, it probably takes more than 2 one-parameter families to
We know that it
insist that
takes
you're a
3
plane.
lines to define a plane.
Well, what do you mean by define a plane? But in fact, as an aside for the this is probably an aside for the undergraduate or graduate students in the room, is if defining what a one-parameter family of lines is a little tricky. But you can. And if you have 3 separate one-parameter family of lines, then your surface is a plane, and you can prove that. But 2, this is called a doubly ruled surface, and you can say things about the structure if you're doing this with you were foreshadowing.
Vision.
Yes.
You know, I did my early elementary in Australia, and I still remember the physical connection,
Right.
I can't remember the rods
Yeah,
called.
but then,
But
that's
you're-
easy.
you're-
That-
I
that's
think they were
easy.
quick to repair that they were wood, and every number from 1 to 10 had its own, rod. And you could do amazing things with those things.
It's
I'm
a
not sure you
combination
can-
class.
Yes.
Well,
Oh,
maybe
that's
before.
amazing that they put them
This was
together
in
so
the-
often they don't
Those
like
are-
siblings being the
I
same.
mean,
color.
I said,
In my,
Well,
yes, as a
so
child.
they don't, that's not really something that they would like shy away because
Right, now you're not using your
Right.
yellows either, are
would
you?
they work
No,
on
you're
it?
not.
I think.
Right,
Would they
So
say,
you're using black, to me,
Blacks and
Maybe
white.
four
work
should
better
be
with
yellow.
this teacher?
right.
and then I'll go back to red after
Well, I
that.
was there
Right.
for you as a whole class, it should have been in this class or that class. And for me, English teacher, I want to work with.
It's true, then it has it.
You're still using big ones, you haven't quite used those.
Well,
Tiny,
these
yes.
are 3 by 1s, but,
Uh-huh.
And then,
oops,
okay, the
Yeah. I was gonna say yesterday's probability session.
not having my own students, students,
That's nice that they welcome you in.
oh yeah, they're because of the teaching.
Oh. All right,
Right.
a bit of a cheat.
But then they also
I got it, I know,
allow you
it's,
to be part of it.
are you, you're part of the MSRI, right?
Yes,
So I-
assistant director.
It's, yeah, the
Awesome.
outside is just
You or a sub
Right.
teacher,
Right.
state that's doing the bigger girls in town.
It's me,
That's you.
yes.
So I'm in Alameda, and I'm totally excited about girls camp.
Send me an email.
Because I teach at the high school in Alameda, and I think that, but I I would
So
love
this is the
somehow the
multiplication
Girl Scouts to
table?
get
Yeah.
sucked in, and I'd love to take out connections.
We would love to connect, Brandy's a
We
lifelong Girl
would be
Scout.
cool
so
if we had
I was
red
just
to
here
go,
for many
with
years,
the
so.
red and yellow
My
so you
daughter
can
is
see
a-
it without having
And I'm a lifetime
color,
color.
lifer.
I think. It's-
So,
Yeah.
We
I was
put
in
white
first class
for
when
That's a
everyone's tent,
perfect
just to
blend,
have a
because they have
landmark.
the community
Oh, I
and the
see, I get
resources
it.
and
Yeah.
safety and the let's get together and chaperones and extra people and giving girls math.
I'd really like to
What's
get.
this?
You know,
We have a church in San Francisco,
How do you,
See, one by one.
girls,
uh-huh.
they go to here before high school, and,
I am always willing to give different presentations like this, or find other people who can lead presentations, help you set things up with money, resources, books, lessons.
so this, each thing is
trying to see
two
something
units is
more.
one.
You asked me for a business.
I was trying a lot of things.
Walking around and
There,
Oh,
I just
oh,
tried
so
like,
you had two by two.
so this is so
wanna
symmetric
do
and there's,
like
you
a
know, you know, what you
That's
want
all.
to use.
One by one.
So I came up with
Thank you.
for some green shade.
If you get somebody, make sure that you can have a room and space. I have a target on this, so
Whatever they're
it's gonna
doing
be,
right now.
try to get some volunteers who can help lead
Pictures
some
are really
sessions.
crazy for me.
They've got all people can lead some sessions, people also get volunteers to help out with It's nice to get math
The
teachers,
green shade.
engineering parents, mountain computer scientists,
Well, yeah, but then you
but
just,
also people to help
repeat
you
the
get
green shade.
snacks
Oh,
for the
red
session and make name tags and buy balloons.
I'm not sure, so at the
What's
very
a
least
group of
it's
people, it's a lot easier.
two different sorts of slides, and it might be the same.
Itself,
Pull it out.
and then you hooked up and all set to go, your training workshops.
But I'm not sure.
There are?
Yes.
Oh, I'd be interested, because I was working in that place when I still was in school, I'd like to start doing some work and it would be nice.
Email.
I will, I
Okay.
will.
Right,
So it has to
that's
be
not,
like.
So,
that's not much
training
fun.
session?
And I
well,
can't
there's
question
some
it.
good things, so there's a couple sessions in the summer that AIM runs. MSRI runs, one in spring. We, very possibly if we get a grant with proposal, we'll start running one
This is a
the
multiplication
first
table?
week of August. Well, so, how are we doing with our mountains? We've got a good multiplication, mountain squash. We've got, may I
Yeah,
pick yours up?
sure,
to
it didn't quite finish
this?
with six,
And in addition, so,
so it's a multiplication.
all right, so I'm gonna,
I love it.
I am going to hold a couple of these things up, and we will have, there will be some structural questions here. And then there's gonna be some thought. I think we did two addition tables. Just for a second, you'll get them back, you'll get them back.
I'm almost done.
Cause. So. So, one of the things that you want to do is you want to start making mathematics. And so, once I have the mountain pass that gets us up into this list of mountains, and we didn't find the mountains, well, we grew up in West Virginia and we're used to excavating and mining and cutting the mountains down. And so here we are mining for mathematical formulas in the middle of these things. And so there's lots of sequences of numbers that come in patterns. For instance, you can have a set of what are called triangular numbers, which would be the number 1, I hope this is visible, the number 1 and 2, 3, 1, 2, 3, 1 plus 2 plus 3 or 6, that's a triangular number. You can also make square numbers, pentagonal numbers, pyramidal numbers, make numbers out of pyramids. And you can write down mathematical formulas. One way to describe this third triangular number is 1 plus 2 plus 3. But we might find other ways of putting it. Like, can you put two triangles together to make a rectangle? Can you put two of these things together and build a rectangle out of two of these guys, which you could actually do with your Legos, and then you'd probably find a formula for what 1 plus 2 plus 3 equals. In fact, would somebody like to build another triangle, say a white one, and combine, so does somebody have an inspiration of how they might combine these two triangle numbers together to get a kind of cool formula? Ah, sure. Put a 1 on top of the 2, like that. But that, then it has this little edge on it. I made the two triangles, yes. So this triangular number and that triangular number.
Yeah, I mean, you can
Put the 1 on top of the 2 and the 2 on top of the 1.
1 on top of the 2 and the 2 on top of the 1.
And then slide your white one over.
Ah. Okay. Like this. I kind of like it. And slide this over. So, does anybody see, based on that Lego diagram, a formula for involving the expression 1 plus 2 plus 3? That's closest I have to white, so
it's the same as half of
Yeah.
times
the same is half of,
4 times 3.
you think you could generalize and figure out a pattern for 1 plus 2 plus 3 plus 4 plus dot 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 plus 16 plus 17? Sure. So with older students, you use letters and you're doing algebra. With younger students, you do a specific sequence of small numbers building up. With students in between, you get to just, 17 is pretty much in, right? You start with middle school students working with big, crazy numbers, and you work with them pretty much the same way you work with variables. And the proof of these formulas is because you can make it out of Legos. But there's something really wonderful here that's happening, not just with the triangular numbers and the square numbers and the pentagonal and the pyramid numbers. Here you've built an addition table. Here you've built a multiplication table. You can start dissecting these things and let your imagination go wild. Let's take a big axe and cut it like this. Or let's take an axe and cut it at a diagonal like this. Kind of a finite diagonal. Let's take an axe and cut it like this. And then let's rearrange those pieces into different shapes, see how we can rearrange them, and write down the corresponding mathematical formula, either with concrete numbers in addition and multiplication signs, or with algebraic variables, depending on the level of your audience and of your sophistication. This is what this activity is all about. It's about discovering formulas in the middle of these things. Let me actually tie these things together a little bit, because before, I'm going to encourage you to start taking these things apart in creative ways. And I love the way that this, Lise was building her addition table. She already started looking at a neat pattern. Let's do these guys, the 1 pluses. Let's do the 2 pluses. Let's do the 3 pluses, where she's grouping together the white ones, the red ones, the blue ones. Maybe she could rearrange something like that blue one, take it out separately, or maybe this red strip, and make another pattern, and then find a really nice formula that might look like this. And that's a nice way of cutting it up. It's creative.
Inside here, never mind.
Right?
You can't see it.
You're getting
So it gets larger and then you can see it.
You're getting nice artistic patterns with these guys. So here's a question. What geometric shape is this? Let's look at the points. These are going to be dots on a line. What about the red segment? And then this yellow.
I think they're all lines with different slopes.
They're all lines with different slopes. What about going in this direction?
It's the same thing.
It's also lines with different slopes. Have you seen a set of lines going in this direction and the lines going in this direction recently? Look at this. It's got green lines going in one direction and orange lines going in another direction. If you think about this a little bit, you might start with, this is the line 0 times. For instance, if you start with the line 0 times, then you get another line of maybe 5 times or 6 times up here. And then when you put the lines going across this, that would be a rigid construction. You could actually make a building like that. In fact, there's this funky winery up in Napa where Hudweiss, I think that's his name, he's a German artist and architect, designed this winery that has ceilings that just sort of rock and roll and do crazy things. And basically, you put one curve, well, in this case a line here and another line here, to mark off spaces, and then connect them up with lines, and that gives you the surface that you're building. The surface that you're building here with a line here and a line here, as soon as you have two lines like that, build up the lines crossing the other direction, that's showing you that this shape, there's a little bit of a scaling issue. Maybe I needed to make these triangles a little taller, maybe I needed to do something with the angle. Those are good questions for high school geometry class, is if I'm going to make part of this really match the multiplication table, what shape should I have started with? Should it really have been a square in the file folder, or should I have started with a different triangle? What angle should I fold this at in order to make this line up with this? Let's imagine that these things are made out of sugar cubes. That would be a project, right? That would take your class a week to figure out, possibly. But it's a nice one to do with a motivated construction. The question is, how much of this corresponds? So we said this kind of looks like the multiplication table because it has two one-parameter family of lines. This has two one-parameter family of lines. Can we actually see, are these, I said that these are the same, that I just line up the lines, but where does this fit in here? How much of this does this represent? Where is 0 times 0 in here?
What's the point? Where's that?
This, you think that's 0 times 0?
Where you think
So a little bit the surface is homogeneous, so it's a little hard to say. So I mean, one model maybe I can make this 0 times 0 goes across here, and then looks like that. Now this is kind of cool, right? I mean, this surface looks the same whether I start over here or whether I start over here. I kind of like the thought of putting 0 times 0 right here in the middle. The reason I like doing that is then I'm holding it flat, and when holding it flat, I've got one flat line is 0 times whatever is 0, and a 0 times whatever is 0, and then here I have the positive numbers coming out. So now, what happens when you multiply a negative number times a negative number? What would this look like if you made a negative times a negative? Would that be a natural looking graph? Would it be as artistic? Would it be easy to build? It's giving you part of the way of thinking why a negative times a negative should be a positive. Definitely not the usual way. And it's showing you, different properties of the multiplication table when you shift it off. It also tells you the equation of this. If you're writing this as an equation in two variables, this is z equals, what do you do with x and y to get this shape? So this equation is z equals x times y. It's just the multiplication table, described in a different way. And so now what I encourage you to do is, after you've got some of these built, let's pass them back, but find cool ways to dissect these and mine for mathematical formula in them. There are some really, really cool ways here. By the way, doing the multiplication table both flat and this amount are really nice tricks. When you do it flat, you can see a lot of properties. Why is this thing symmetrical across this line? And it shows you a nice representation. So if this is 0 times 0, so this is like the x, y axis. So this is x, this is y. So when x is 0, 0 times 0 is 0, 0 times 1 is 0, 0 times 2 is 0, this line is 0, 0.
Alright.
And then if I do 0 times 0, 1 times 0, 2
Yeah, I
times 0,
really like seeing it versus even an
so
odd,
this
you
is
know,
1
and
times 1.
also just watch a few other points. We marked 10, where was there?
And then 0 so negative.
We have to get a few more to finish the 6, kind
So I
of
go
and then
negative
we
2
have to see what kind of,
times negative 1, 2.
hands up and you got this, right?
What about this, is it?
Oh, this would be, if I go this way, this would be a negative x
About
times
having,
which would be negative.
more than just seeing it, like
So
this.
on this side I go down, on this side I go down, and on this side I
The
go up,
difference
and on
in
this side I
how
go
quickly
up.
it grows,
There's no, I like the little ones that she has, I didn't even see that you had those. This is what we were using, this is the square one, we had to use, we used in doubles in a couple of places just to fill up. Yeah, there's the elevator, we need to get some more. We need to add some elevators.
Here's another section.
Maybe we'll get more or just come up with,
He said he wanted us to dissect.
right, to dissect it in some way.
So, I took one of the
Very cool. So now it's just only to keep it open, there's two favorites that there's no other. Just because.